Howdy, 8th grade. Today we're going to look at a bit of special factoring. So we're going to be factoring some more trinomials. And we're going to look at some patterns that we can use to solve these a little bit more easily. But first I want to make sure that we review just how to factor in general. So that's where we're going to start. And I want to start with x squared plus 6x plus 9. So if I want to factor that, we want to remember that I'm going to try to find two numbers that are going to multiply to 9 and add to 6. So what two numbers multiply to 9, add to 6? Well, if we're multiplying to 9, I either got a 1 and a 9. 1 times 9 is 9. Or a 3 and a 3, because 3 times 3 is 9. But there's really no other thing I can use. So these are my two options. I need to find which of these is going to add to 6. 1 plus 9 is 10, so it's not that one. But 3 plus 3 is 6, which makes me happy. So that's what I'm going to use. My numbers are 3 and 3. I end up with x plus 3 times x plus 3. And if I multiply these together, if I FOIL it, I'll end up back to x squared plus 6x plus 9. So let's look at a couple of patterns that we can have. So my first big new thing for today is what's called a perfect square trinomial. That is not how you spell square. S-Q-U-A-R-E. There we go. A perfect square trinomial. So this is what's going to happen if we start with something like x plus 2 squared. If I have x plus 2 squared, that would be x plus 2 times x plus 2, and I end up getting x squared plus 4x plus 4. If I had x plus 3 squared, I get x squared plus 6x plus 9. So what's always going to happen here, when I have a perfect square trinomial, what I get if I have a plus b squared is a squared plus 2ab plus b squared. And this is something that I'll always be able to factor fairly well. So how to tell if I have a perfect square trinomial is that I'm going to have, let's just plug in an x plus a, and we'll see what this looks like. So here a is going to be our number. So like up here, 3 would be A and 2 would be A. But I'm just going to say for A, and we can kind of use it more generally. So x plus a squared is going to be x squared from the x plus 2ax plus a squared. So if I have a polynomial that looks like x squared plus 2 times something times a plus that something squared, it's going to end up as a square factor, just like this. So let's look at a practice problem, just to know what this looks like. If I have x squared minus 2x plus 4, is this a perfect square? Well, looking at this, I know that I would have to be able to multiply something by 2 to get to negative 2 and square it to get to 4. Well, the thing that I would have to multiply by 2 to get to negative 2 would be negative 1, and negative 1 squared does not equal 4, so it's not perfect. This doesn't follow this pattern. So this right here is our pattern, and this does not follow it, so that means not perfect square. But that's all right. We can find one that is, and then we'll factor it out. So if I have, let's do, as an example, 36x squared minus 48x plus 16. So looking at this problem, the first thing we want to do is to find a common factor and pull it out, just because this is kind of a lot of big numbers, which we don't necessarily like too much. So we're going to try to pull out as much as we can. Let's go ahead and make factor trees. This is 36x squared, 9 and 4, 2, 2, 3, 3 golden. My 48 here is going to go into a 4 and a 12. It's 11x. 4 is 2 and 2, 3 and 4, 2 and 2, and 16 way over here is going to be 4 and 4, which is a whole mess of 2's. So if we're looking for what we have in common, what's going to end up being in common is that all three of these trees have a couple of 2's at the end. So I'm just going to remove those and bring those out front. So I'm going to take these 2's and have 2 times 2 out front, in front of a parentheses. So everything else is going to go inside the parentheses. So I took out the 2 and the 2 from this. What's left is a 3 and a 3, which gives me 9, and my x squared, minus, make sure we keep the minus here. What's left here is a 3, 2, 2, and x. 3 times 2 is 6, times 2 is 12. So I have 12x. And then plus again, what I have here is 2 and 2. And 2 times 2 makes 4. That's what I'm looking for. That took me longer than it should have. So 2 times 2 up front, also 4. Let me fix that. I'm just not having it with 2 times 2 today. And now we're going to try to figure out what exactly this is going to equal. So since we know we're looking for perfect squares, that's going to give us a little bit of an advantage. I know that 9x squared is 3x times 3x, and 4 is 2 times 2. So that gives me a little bit of a hint. But looking at the middle here, I have this negative 12x. So that should be the first thing times the second thing times 2. So I have 2 times 2 times 3x. I get 12x. So it's looking kind of like a perfect square, but I have this negative here that's not quite working for me. But what if I said 4, instead of being 2 times 2, was negative 2 times negative 2? Now if I do 2 times negative 2 times my 3x, I would get negative 12x. So because I have one thing squared and another thing squared, and this middle term is the two things multiplied together times 2, just like we had in our pattern way up here. So we have one thing squared, another thing squared, and the things multiplied together times 2. That means that we can write this as a perfect square. So our two things are the 3x plus our other thing's the minus 2, and we can write it as that squared. And just like that, with our little nifty trick, we are done with factoring. And I want to show you guys one more that's actually much easier than this. So this was the hard one for the day. The easy one, number 2, the easy one is going to be difference of squared. Difference of squares. So I'm just going to show you guys what this looks like because these are going to be pretty easy to spot. And this is what we're going to do if we see something where we have one square number, like 9x squared, square number. So this is 3x times 3x, so it's a square number. And then a subtraction, which is very important. And then another square number, so we use 16, so another square. And anytime we can see something like this, it's very easy to factor it. What we're going to do is we're going to have two different sets of parentheses. And we're going to have the two things that square to our numbers. So I know that 16 is 4 squared, and 9x squared is 3x squared. So I'm going to have these two things, and because it's a difference, I can just put them in these boxes. So I have a 3x and a 4, and I have a 3x and a 4. But like we said, these aren't perfect squares. If these were perfect squares, I'd be able to put plus and a plus and I'd be done, or a minus and a minus and I'd be done, but that's not what we have. We have a difference of squares. So we're going to put a plus in one and a minus in the other. If you FOIL this out, we'll find that we get 3x and 3x is 9x squared, 4 and negative 4 is negative 16, and everything else cancels out really nicely. So anytime we have a difference of squares, we just have to find their square roots and have one where it's added and one where they're subtracted, and we'll be good to go. So let's try one more problem like this just for fun. What this is going to be is I'm going to have x squared minus 4. So this is a really easy one. I got two numbers that are both square numbers. So this right here is x times x, and this right here is 2 times 2. So my numbers are going to be x and 2. So what I want to do now is write my parentheses. One's going to have an x and a 2, the other's going to have an x and a 2. And to make this work, I need one with a minus and one with a plus, and just like that, I'm done. In any case, I will see y'all in class tomorrow, and I hope you'll have a wonderful day.